Okay, let's get started again. Now the next one should be fairly simple. This one should be simple one. Okay, power requirement. Okay, now do you want your handphone to consume high power?
No.
Yes or no?
No.
Ask yourself a question.
No.
You want your phone to consume high power or low power?
No. Low power.
Right. Your laptop, high power, low power?
Low power.
Low, right. Why low?
So the battery can last longer.
Correct. No? You answer my question. Why? Because the battery can last longer, right? So I want anything, any gadget or any device that you have must be low power consumption, right? The lower the better, right? Ideally, very little. Okay, so same for a chip, IC, Okay, you can add this little IC here, right? Okay. Now this fella here, I want it to be low as power, as low as possible, right? So I want it to be lowest as possible, lowest in the world if possible. I want it to be as low as possible, not lowest. I want it to be very low. Okay. So now, basically, if you look at it, right, this IC will consume some power, right? VCC, maybe ground, right? Your chip will definitely take VCC, right? So when you have a VCC, you will take in some current, right? You will draw some current, right? So we call it ICC. Okay, I don't know what's the term for it. ICC. What does it mean? ICC stand for what? CC stand for what?
The current from the solar.
Is it CC got meaning? CC. I know it's a source current. Supply current. I don't know what is CC. Supply current. Okay, supply current. You're right. Okay. Now this supply current has to be as small as possible, if you can, right now. And then okay, so we would then define ICC average. Average.
ICC is supply current.
Yes, supply current. It's on page 12 of your survival guide.
This one like VCC lah.
From VCC lah.
Yes. This one going to the chip, ICC. So you have the ICCH and the ICCL. So the high and the low. You get what I mean? So what does it mean? If you look at your notes, I think it explains quite well this one. Okay, so if you look at page 12, right, of your survival guide, okay, so you see that when the gate is high, you look at the picture there, look at your picture, page 12, when your output gate is logic high, it draws a certain amount of current, right? So you have the chip there, right? You just draw something like that. So when your output is high, when it's in the high state, right?
Binary 1.
Yeah, okay, yes, high, logic 1, yes, correct. Okay, you will draw something from the chip. Imagine this thing is the chip, it's the IC. This thing is the integrated chip, IC, right? So of course you have the VCC, right? Right? So you have the current.
So the highest is all 1, then the lowest is all 0.
Yes, correct. So you consider the worst case. Let's say inside got 4 chips, let's say 4. Okay? You understand this picture? This is the schematic of the chip. Let's say inside got 4 gates. So when all of them are high, you draw this thing called ICCH. It's the maximum current. Okay, called the current drain. Okay, and then of course when this one is reached low, yeah, correct. You have another case. This output all low, right? This whole thing is low state. Then you draw a current called the ICCL, which is when it's like the low state. So you take the average, right? So this one is the summation of these two, CCH plus ICCL divided by 2. Okay? So you get the average current by the chip.
You see the
you decide one. The worst case you control one. This one high or low is you design what you control this chip, right?
the got 3 input, the thing got 3 input.
Which one? This one
Yeah,
okay. Yeah, why?
Why 2 1 then equals to then 3 1 equals to 0.
3 1 equals to 0. The 3 input NAND gate. No lah, don't worry about the picture. That one just to illustrate to you. I'm not saying that this one you don't care about this one. Okay, just to illustrate to you that if it's high, it means 1 1 1 1, right? If it's low, it means 0 0 0. Okay, don't care about this one.
Oh,
Don't worry.
main gate.
But it's a main gate, you're right. Main gate.
All one invert 0 here.
Oh. Sure. Yeah. Question. Which one? 110, you mean which one? Yeah. The output. No, we take the worst case. You consider the extreme case. You know what I mean? Whenever we look at this kind of thing, right, we always consider the extreme case. The worst case is all turned on, right? That draws a lot of current. And the other case, extreme case, is when it's all off. Two cases only. You don't go and consider the in between. There is no ending. Which one? Right? You take the worst. Okay, then I take the worst. Get it? Yeah. Can, huh? Then of course the next thing will be to calculate the power lah.
Then the VCC we take the average.
Yes, take the average. Take the power average. Power, we know power V times I. Right? Power. Voltage times current, clear cut. So you take the power average, you take the yes, this one ICC average, which is from here, times the VCC. Voltage is constant now, by the way. Voltage is constant. Your supply chip.
Give him 3 values.
Which one?
Mean, normal, max.
For which one?
The data sheet.
For VCC, is it? No, that is you will depends on which one you take. Normally you take 5 volts. What the chip specification tell you is that the maximum you can do is 5.25.
Oh, yeah.
Okay, minimum is 4.7, but you normally take the nominal value 5. Yes, it will be given in your ICC. No. The one you have to
ICCH, ICL,
given. Sorry, given inside your table. Okay. So power is this. So which means that you need to know this, ladies and gentlemen. This one you need to know. Thank you very much. Quite heavy duty, this one. Very heavy duty.